The purpose of this demonstration is to show what happens in the design phase of a network to determine if the radio power and the antennas are the correct ones for the choices made. So in this particular case, we have one root node and a number of relay nodes that are covering an entire area. And as you can see, the network health monitor says that at least 3 nodes do not have a backup, as in another node that can support them. So we would essentially either move nodes in closer, or we would start an auxiliary system, a secondary root node, to try to help make everything more healthy. So beyond that, as you can see, the channel management here is demonstrating that we are using up quite a few channels because of the closeness of the space. And some of that is also, of course, driven by the fact that we have a large range. This dotted circle essentially shows me that the minimum range I need to support for the nodes that are connected to me. And it shows you the overall throughput, which is the connection, the overall throughput from, it says beacon strength, but it essentially means the effective beacon strength that the system would see if it was connected directly to the root node. Now, I can change the parameters of this network by playing with the maximum number of hops. And let's for a moment reduce the number of hops, which we did a minute ago. And we can see that if we are 1 hop away, nothing works. And if you want to have a 1 hop network, then it forces you to at least look at how you would have, in this case, 3 roots. In the event that we don't want a 1 hop network, but we are willing to deal with the latency and throughput of a larger network, then we can probably remove everything and have everything running as a single root node. And then we have some other choices that we can make, which is really the throughput trade-off. In other words, how will the nodes connect to their parents? Will they prefer to connect with better throughput, overall throughput, to a neighboring node, or will they try to make a longer range connection directly to a root node? And so that parameter here is essentially changing that setting. And if we can play with it, we can see that as we change this setting, I don't see it moving. That's probably because of my network here. There you go. So this is the 0, which is the default setting. But as I move it forward, I can get a sense of when changes will start occurring for how I will want my network to be. This particular case is very hard because everything is already connected. But if we changed it, so for example, here you could see it changes back to preferring to connect to the root. But if I change the value back a little bit, it will now connect to someone who gives it a better overall throughput. As I start loading the network, I can start seeing how the system is going to behave. So for example, if I slow this down a bit and I start loading the network, you can start seeing how the pattern depletes. You can clearly see that as you have more hops, there is a lot more data that is traveling back and forth before it actually gets into the root node. There are other features here like dynamic channel management, dynamic threshold management, and there are also tools provided for changing the signal mapping so that you can play with different parameters. This is fundamentally a tool used during the design phase, and it allows you to essentially determine which models, which radios, which antennas you need for a specific range that you wish to meet a set of criteria for. So obviously, one shoe does not fit all. When you start designing these kinds of networks, we do need to sort of figure out what would be the correct setup for a particular node formation. Thank you for your time.